All right, today's lesson is Appendix Lesson 61. It's simplifying equations with decimals. What's our objective, class? Get ready?
Simplifying equations with decimals.
Very good. Today we're going to be solving equations that look like this, and we're going to learn how to clear the decimals first, because sometimes the decimals make it a little more cumbersome, lining up decimals, borrowing with the zeros. So I'm going to show you a cool trick to get rid of the decimals. First, look at the largest decimal placement. I got to think of the right word. It's the digits. Okay, there are 3 digits to the right of the decimal. This is the largest one. So what we're going to do is get rid of this one, and it'll take care of all the rest. So if I were to get rid of this, these 3 decimal places, I would multiply by 1, 2, 3, or 1,000. So 3 zeros, because I need 3 places to get rid of. If I multiply the right side by 1,000, I have to keep a balanced equation and multiply the left side also by 1,000. What does this do? Moves my decimal over 3 places, and I'm left with 4 on the right side. But I got to do the same thing on the left side. I can distribute, but can I do a little shortcut now and just go, hey, that's going to move it 3 places. 1, 2, 3. Fill in my 2 zeros, so negative 200 plus, move this one 3 places. 1, 2, 3. Fill in my 0 there, that's 30. Copy my x equals 4. Hey, look at that. That's like a little more friendly to work with. There's no decimals anymore. It's a little bit easier to work with. So now I go back to what I've already learned before. Isolate x, start farthest away from x, and eliminate by using inverse operations. We're going to add 200 to both sides. That gives me 30x equals 204. And then to solve for x, again I have to isolate x. I have to get rid of the 30, so I'm going to do inverse operation. Do it to both sides to keep a balanced equation. Gone. That leaves me with x equals 30. Thank you, 6.8. And that's it. So what we did is we cleared the decimals first, then we solved it using stuff we already knew how to do. Spencer.
So with this, why would you add 200? So you're just trying to get it up to 0?
Oh yeah, we want to. So because we want to isolate x, we want to get rid of the negative 200 and the 30. So we do the inverse operation. Okay, great question. That's why we had, like, where that huge number came from. Remember, we multiplied by 1,000 so that we could move all the decimals over. It's kind of cool. You don't always have to do that, but in cases where it's like all decimal places, you can move them all over at the same time, and it makes it a little bit easier. When we
Wait, but you're adding 200 to the 30?
We added, well, we kept a balanced equation. We added it to both sides. Is that what you asked?
Well, wouldn't you?
You're wondering where it came from, the 200?
No. Never mind.
Okay, keep thinking if you still think about it.
We're asking why you added when there's already a plus sign there. Why didn't you subtract instead of add, because that's the opposite.
Okay.
of
Let's say, that's a good question. Let's say, usually I subtract from both sides. Let's say I did that. What's negative 100 minus 200? Well, that'd be negative 400. Did that eliminate anything? No, I couldn't put that cross through it because that's not 0. I want to make it so that this equals 0. Okay, good. Kaylee?
But how come you didn't subtract 30x from both sides?
On my first step?
Yeah.
Because it's closer to x than
Yeah. I want to get x alone, so I have to start farthest away from x and get rid of this first.
Okay.
And then I start on 30. Okay.
What
Avery?
happened to the plus sign in front of the 30?
This one? It's still there. So that just means it's a positive 30. Right? These are all very good questions. I like that you're engaged and you're listening. Okay, think back a few years when you learned how to divide, right? You did 0.9 into 6.3, and your teacher said, oh yeah, you got to move it over once and move it over, so then you really have 9 into 63. could you do that? The math law says you really what you did is you times by 10 over 10. You times by 1. That moved the decimal once and moved the decimal once. So can you do that in a proportion like this so that you can clear, oops, that one right there.
Yes.
So you can clear the decimals? Yes, you can. So, let me get rid of all this. So let's see if I move the decimal here and here, because I times by 10, times by 10, I really have 51 over 3 equals 34 over x. And then I can use my easy cross multiplication to solve for x, right? Multiply these two, divide by 51. Okay, Joseph?
Wouldn't you still have to multiply the 3 4 though?
Great question. He says if I did the left side, if I multiplied the left side by something, do I also have to multiply the right side? What did I multiply the left side by? 10 over 10. 10 over 10 is equal to 1. Ah, the very good question. If I multiplied the left side by 1, the right side is like multiplying by 1 too, so I don't really have to change anything. Is it always easier to clear the decimals? Do I always have to? In this case, I could go, okay, well look, I got these decimals. Would it work if I said times by 10, times by 10? It'd work on this side, but this side, it won't work. Why? Because 10 times z over 4.6 is 10z over 4.6. Did it clear my decimal?
No.
No, it won't work. Okay, so I would say if your decimal's in the denominator, just leave it there. Just don't, I wouldn't even worry about clearing the decimals. I would just do inverse operations. Okay, I'm left with z over 4.6 equals, that would give me 5.2. And then from here is, what's the 4.6 doing to the z? It's being divided. What's the opposite of division, think? Is that ready?
Multiplication.
Multiply. So I'm going to times both sides by 4.6. Gone. Now z equals whatever that turns out to be. All right. That wasn't so bad. You have 4 practice problems. Take out your whiteboards. Your practice problems are A, B, C, and D. Par is 6. Show me your work so I can help you if you make a mistake.